Hello everyone, this is group 2 and this is our second case analysis, and for this particular case we're going to be tackling case 9.2 titled Money in Motion. So here we have our case facts. So as we know, Jake Nguyen, the manager of Asian Foreign Investments at Grant Hill Associates, is facing a financial crisis due to the unexpected collapse of the Japanese market. Now this collapse has significantly devalued the yen, affecting all other East Asian currencies. Grant Hill Associates had heavily invested in Japanese markets, increasing its holdings from $2.5 million to $15 million just a month ago. Now, due to currency depreciation, Jake must determine the most cost effective way to liquidate these investments and move them into safer assets, primarily US bonds. Now, Grant Hill, the firm's president, orders Jake to move all the investments out of Japan, Indonesia, Malaysia immediately. However, strict government imposed transactions limit and high transaction costs complicate the process. Jake must find an optimal currency exchange strategy to minimize dollar returns, at the same time minimizing conversion cost.
Jake needs to solve the problem of the case by finding an economical approach to convert Grant Hill Associates' holdings into US dollars despite the challenges of exchange rate fluctuations and transaction fees complexities. His company encounters considerable limitations from East Asian governments on foreign currency withdrawal, due to which money exchange across international borders becomes more difficult. The core problem requires choosing an optimal plan that will reduce expenses when changing the held Japanese yen and Indonesian rupiah and Malaysian ringgit into US dollars, as well as accounting for transaction expenses from large scale currency transfers. Jake needs to ascertain a cost efficient exchange methodology for the foreign currency holdings through an analysis of existing rates and secondary costs, which represent percentage values of converted currencies. Jake must determine the best approach to handle currency exchanges because the demands pose constraints, but he should also contemplate their financial effects on Grant Hill Associates.
As for the inputs, to set up the problem, we define nodes as currencies such as yen, rupiah, ringgit, US dollar, etc. For the edges, it is the currency conversion paths with associated costs and limits. For the supply, it is the holdings in yen, rupiah, and ringgit. And the demand will be desired output in US dollars.
So for this problem, we must use the minimum cost flow approach, where we use the currencies as nodes, exchange paths as edges, and transaction costs as the capacity. By using this model, we will find the best transaction sequence, choose the cheapest path, and adjust for high transaction costs. So this is what our model looks like. The orange cell represents the objective cell, while the yellow cells represent the variable cost. As you can see in our model, yen, rupiah, and ringgit are all supply nodes. Peso, pounds, euro, and Canadian dollars are transshipment nodes. And lastly, US dollar is the demand node. So for the net flow, we will use the formula sum if, select the from column, comma, and then select the node, comma again, and then select the yellow variable cell, minus sum if, select the to column, comma, select the node again, comma, and then select the yellow variable cells. We will do the same formula for the rest of the nodes. So for the transaction cost, the values differ, but they all use the same formula, where we multiply the same row variable cell with the transaction cost given by the book. For the last formula, it is for the objective cell, which is sum product, select all the variable cells, comma, and then select all the transaction costs. Lastly, all we need to do is set up our solver. First, select our objective cell, which is the orange cell. Select our variable cells, which are all the yellow cells. Set the solver to minimize. Set the engine to simplex. And then do the following constraints. First, the net flow should be equal to the supply and demand. And next, the shipments should all be less than or equal to the capacity.
Okay, so as for the formula, we model this as a minimum cost flow problem where the goal is to minimize total transaction costs while ensuring maximum conversion to US dollars. And here's our objective function, where x sub ij is the amount converted from currency I to currency j, and c sub ij is the transaction cost percentage associated with the conversion. As for our constraints, here it is. Note that for each currency node I, the net flow must be equal the available supply b sub I. Now here's the transaction limit, and note that each transaction must not exceed the permitted limits of L sub ij. As for our non-negativity, it's x sub ij, which should be greater than or equal to zero, meaning that the negative conversions are not possible. All right, now here is our node graph.
So for question B, running by our minimum cost flow model, the lowest possible cost that the company can attain is $4,938,000. We acquired this number by transacting the yen into pounds, transacting the rupiah into US dollar, Canadian dollar, euro, and pounds, transacting the ringgit into US dollars, euro, pounds, and pesos, and finally transacting the remaining currencies of Canadian dollars, pounds, euros, and pesos into dollars. And for question C, the process is the same but we have removed the transaction limits, which results in the answer of $4,060,000. And lastly, for question D, the transaction cost for rupees has been quantified, which raised the cost to $5,908,000.
Now, for letter E, Jake must also consider that the currency exchange rates are volatile. So by the time he executes his plan, the exchange rate might have changed drastically.